Do you have a good claims history with a previous insurance history of at least 2 years? Are you a single financially independent woman or over the age of 55 but not a pensioner yet? Are you a professional? If yes, SMS cover to 555 and we will call you back to get you insured for less.
When the live game's about to start but you're stuck here, we've got an app for that. Missing your favorite show because the fridge is running low? We've got an app for that. Stuck watching what she wants to watch? We've got an app for that. Waiting for the bus? App for that. Working late? App for that. And if the power goes out, we've got an app for that too.
It's all for you.
The DSTV Now app is the entertainment solution for anything life can throw at you. Simply download the app from your app store and add your DSTV account information to activate the app and start watching. Whenever, wherever you have a charged device and an internet connection, you have DSTV Now.
Grade 12s, we are then still looking at logarithms. In the previous lesson, we looked at the conversion from index notation to logarithmic notation. So we said 2 to the power of 3 is 8, log base 2 of 8 is 3. So this is index notation. And this is then log notation. This is what we want to do, and that was what the first lesson was about. Now today we're going to look at the log laws, because we have certain laws that we will apply when we have logs. Now the first three you've already learned last year, then we're coming up with new ones now. The first one says if you have log A, B, then this is log A plus log B. This is now to base 10. The base is 10. I'm not going to write it in if it is base 10. So if we multiply, we add. And that was actually also the rule with indices. If we said a to the power of x times a to the power of y, then it was a to the power of x plus y. So if we multiply, we add. This is writing as single logarithm. This is writing as separate logarithms. And that's what we're going to do today. The second one is now log A divided by B is then log A minus log B. So if I divide, I subtract. And then the last one that you've learned was log A to the power of B is B log A. B log A. So we bring down that little power. So this was the first three log laws that you've already learned last year. Now, the new ones that we want to come up with now is when we change the base. So this is where we change the base. And that's then the following log laws. So if I have log A, B of B, then I can say that this is log B over log A. Log B over log A. So what you do here is you change them all to base 10. Another one, it's the same thing actually, is that we can say log A B is then 1 over log B of A. Log B of A. So it's also a change of base, and then it's this reciprocal. We will use this then also quite often. And then the last one is when I have log 1 over a of b, still changing the base, then it is negative log a of b, changing the base. So that's the 3 new ones. Let's just look at them again. If I multiply, I add. If I divide, I subtract. Bring down the little power. Now it's the change of base. So this one becomes log b over log a. Here you can also, this is the same thing, you can also write it as 1 over log b over a. And then when we have a fraction as a base, it becomes negative log a of b. So that is then the log laws. So in the textbook now, we're going to start now on page 56. And there you will see there's the basic log laws. There are very nice examples there in the book. Let's look on page 58. There's a few errors to watch for. That's what it's not supposed to be. Look at the first one there. Log, if it's log x plus y in brackets, it is not log x plus log y. It is also not log x times log y. It is also not log xy. And the same then with the subtraction there. All those laws are not true. The ones that we've seen just now are then the correct ones. So we're starting now with exercise 15, and this is on page 59. So this is now about writing it as a single log, and this is a single log, log AB, or like writing it as a separate log, log A plus log B. And we're going to vert it from the one side to the other in this exercise. Right, so the first one is then log 2PQ, which is log 2 plus log P plus log Q. If I multiply, I add. Number 2, log 2 over PQ. So this one is log 2, but this is now division, so it becomes minus log P minus log Q. Because we divide, we subtract. Number 3, log PQ squared. So this means that in the first place, we're going to square each one there. And then it's that third log law, bring down the power. So this will be 2 log P plus 2 log Q plus 2 log Q. Number 4, log 2 over PQ squared. Again, you will square each one there. Here it will be log 2. I'm dividing, so I'm subtracting now. Each one will be to the power of 2, so it's minus 2 log P minus 2 log Q, 2 log Q, log Q. Question 5. Log 1 over P, you will see they say simplify it as far as possible. So this is log 1 minus log P. If I divide, I subtract. But we can give an answer for this one, because remember, if there's nothing, it's a 1. So the question is now 10 to the power of what will give me a 1, and that is 0. So your final solution is negative log P there, negative log P. Number 6, log PQ over P squared minus Q squared. And we should see that as a whole, like in brackets actually there. So then it will be log P, I'm writing it as separate logarithms plus log Q, because I multiply there, and now I'm going to subtract log, and we keep this P squared minus q squared in brackets there, in brackets. Question 7. Log p q n plus m. If I multiply, I add here, so it will be log p, and here we'll have to bring down that power, but we're going to keep it as a whole, so n plus m, I keep it as a whole, log q. Because you can see this is addition, and we are busy now here with multiplication. Number 8, log pq over p plus q. Same thing here. So it will be log p plus log q. And then because we divide here, minus p plus q, I will write it in brackets, log, this is now wrong, the log should be here in front, minus log p plus q. I will write it there. So the bracket is there. Number 9, log, now we've got that square root there, we must just apply our rules. It's the 5th root of q to the power of 10. So I will write the first one as, let's just simplify it there first. So it's log, and then it's 3 over 5. So it's p to the power of 3 over 5. And then 5 over 10 is then q a half. Can you see? First removing the root in there. And then I would say bring down the power, so it's 3 over 5 log p minus a half log q, a half log q, there. And then the last one, number 10, log, it's again a square root there, pq over p, and here those two p's can cancel out. I can do that right at the beginning. So the answer is then, remember, then it becomes now log q to the power of a half, lifting the root, and then the final answer is a half log q. So this was now writing it as separate logarithms, Now, the next one is now exercise 16. Exercise 16 on page 62. Page 62. There are very nice examples that you can work with in the meantime. So now we say write it as a single logarithm. So now we're going to do the opposite operation. So working from separate ones. So the first one says log A minus 3 log B minus 3 log B plus 2 log C. So that means now I have to combine it. This one is log A. So, and I just do it with my log laws. So I'm going to say that this is log A. There's a positive, so I'm going to multiply with this and taking up that power, so it becomes c squared there. And because I minus, I divide, and there's the b, log b. Writing it as a single logarithm. So you can see this is now a single logarithm that I have there, using my log laws. The second one will now be log base t. They are all the same base t, so the log laws only work if you have the same base. So it will then be a times y. There I add, so now I multiply over bc, number c. So this one will then become log, and then it is x over y squared minus log x squared. And then because I minus, I'm going to divide. Because I minus, I divide. So what we're going to do now here is, because we subtract, we're going to divide. So it becomes log x squared over y squared. First, just removing that power there to each one then there. And now because I subtract, I have to divide by x squared. Now, if we divide with a fraction, we know that you actually multiply with the reciprocal. So it's now x squared over y squared. And then we multiply with 1 over x squared. I divide with a fraction. So this can cancel out, and your answer is then log 1 over y squared. 1 over y squared. The next one is number D. Now that one will be log x plus 3. Look, we keep it in brackets there, but I bring up that little power there. And then I divide with that 3x minus 2. Now, the problem is now that there is a minus 1 in the middle, which is not logs. It's a number value, and I cannot work with logs and number values at the same time. I have to change this to logs. If you look there, you will see that this is log base 10. There's nothing written, so it is 10. Now, remember what we said, 2 to the power of 3 is 8. Log base 2 of 8 is 3. So that means 10 to the power of 1 is equal to 10. So the 1 will be log 10 of 10. It will actually be log 10 of 10. So I'm going to multiply this by 10 from that minus 1. Number E, the next one. Number E. So this is now vitally important where we get those numbers in there. Number E will be log base 2. The base is 2. So in the first place, I will have 3/4. Now, which other one is a positive? The x, can you see? And then which ones, and then the 5 squared, taking up that power. And which ones are we going to minus? Log 3. But then again now, so now we've got a minus 1 there as well. But this time the base is 2. So the question is now, log base 2 of what is going to give you a 1? So 2 to the power of what is going to, that 1 should now be in that x's place. So it's 2 of 2. Remember we said if it's the same, then it's a 1. So it means that I will multiply now here by 2. Can you see where that comes from? And then if we simplify this whole thing, then we have log base 2, and it's then 25x over 8. I just simplified all those numbers then there. Number F. This is base 7 this time, so it's log base 7 of 12. I will multiply it with a 1 over 42 because that is addition. And then we will divide with that 98. And this is then log base 7 of, and if you just simplify this whole sum, it is 1 over 343. Just simplifying that one. Right, question 2. Evaluate. That means we have to get an answer now there. Now, the first one is log base 3 of 729. And I'm going to change it to index notation to find the answer. So the question is 3 to the power of what is equal to 729. Now, to be able to solve it, we have to change this one also to base 3. And you do that by using this prime factor method that you will divide there. And this is then 3 to the power of 6. So I can write now here that this is 3 to the power of 6. Your bases are equal, so the answer is 6. There's my answer. X is equal to 6. Number B. 3 to the power of what is equal to 1 over 9. changing it to the same base, this is then 3 to the power of -2. So your answer is -2. Number C. Again, I write it as a single log there, so it is log 5 squared, multiply by 8, divide by 4. And this answer, if you work it out there, it is 2. Then you get a 2. Because, let me just explain there, you get log 100. And now remember again, this is base 10, so 10 to the power of 2 is 100. So that's how I get the 2 there, that value there. Number D. D is then log 8, multiply by 125, and now you will see there's a -1, so it will again be divided by 10. 10 of 10 gives us the 1. And if we simplify here, we also have log 100, and the answer is 2. Same reason as that one. Number E. There you can just press the calculator. It gives you 1.5. Number F, again, press the calculator. Log 64, divide by log 4, and the answer is 3. And the last one, G, that is then log base 3 of 81. And I divide with 1 over 9 because I subtract. And if you simplify this, the answer is 6. The answer is 6 there. A very important exercise is now number 3 on page 63, solve for x. And this is what they're going to ask in the exam. So the first one is log base 2 of x minus 1 plus log base 2 of x, and there's a mistake in the book, it should be plus 2 there, is equal to 2. Otherwise, it doesn't want to solve. So, can I apply my log laws? No, because here I have a number value, and that is a problem. Everything must be logs. So I need to change this now to log base 2. And the question is now 2 to the power of 2, that 2 there, is 4. So that's what you should write down there. Now applying my log laws, so log 2, x minus 1 times x plus 2 is equal to log base 2 of 4. Changing the number value to a log, and it is base 2, that's why it's a 4 there. And what we can do now is to cancel the logs on both sides. What you do on the one side, you do on the other side. And now it becomes a trinomial. X squared minus x minus 2. Bring that 4 over, minus 4 is equal to 0. So we have x squared minus x minus 6 is equal to 0. And now we factorize it as a trinomial. And the factors will be 3 and 2, minus and positive. So now we're going to say x is equal to positive 3, or x is equal to negative 2. Oh, this one should be a positive x here. So it is then so this one is a positive and this one is a negative. So there's the positive and there's the negative. Now, we're going to say that this one is invalid because your logs must be, this must always be positive. So the answer is going to be that one. Very important work. This is what you're going to get in the exam. The next one, log base 5 of x plus log base 5 of x plus 4 equal to 1. Can I use my log loss? This is base 5, so it is base 5, and the question is 5 to the power of what will give you, or 5 to the power of 1 is 5, so it's 5 of 5, log 5 over 5. Now I apply my log laws, so log base 5 of x plus 1 is equal to log 5 of 5. Now we can cancel the logs on both sides and again a trinomial, x squared plus x, I bring that one over, minus 5 is equal to 0. So if we factorize now here, it will be x and x, 5 and 1. Right, let's just look here. I made a mistake here. It is then x plus 4, 4x and 5. If we factorize now, this one is positive and this one is negative. So x is equal to negative 5 or x is equal to 1. And this is then the solution. This one is invalid. Invalid. We must work with values here. You must work with positive values. Then the next one, log x minus log x 1 and is equal to 1. Clause? No. I need to change this one. So this one of 10. My base is 10. 10 to the power of 1 is 10. So now I can apply my log laws, log x, and I'm dividing, because it's subtraction, is equal to log 10 of 10. I can cancel the log on both sides. I will multiply with the LCM, so x is equal to 10x minus 10. I multiply with the LCM. So now if we bring this over, then I will have negative 9x, which is equal to negative 10, and the solution in then is x is equal to 10 over 9. That is your solution. Number D, log base 3 of x minus 2 log base 3 of x plus 1 is equal to 1. Can I work with my log laws? No. I need to change this one. So this is log base 3. Look. And what's a 1? 3 of 3. Your log laws now, log 3, log base 3 of x, divide by x plus 1 squared. I also bring up the power and I divide, is equal to log base 3 of 3. So we can cancel on both sides, and then I can multiply the 3 with this one. So this is now x is equal to 3, and I multiply here x plus 1 times x plus 1, because I have to square it. So x is equal to 3, and this is then x squared plus 2x plus 1. Now we can multiply with the 3 here, so it is 3x squared